Up next in Chapter 8, we're going to look at the components of a two-proportion hypothesis test. There are still 4 steps, and they follow the same outline. There are just a few key differences. We're going to be comparing 2 populations here. So instead of looking just at one group, maybe teenagers in general, you might compare 16-year-olds to 17-year-olds. But when we're comparing 2 populations, our main concern is the difference between the 2 groups of study. It doesn't matter if the first group is 80% and the second group is 90%. Or if the first group is 20% and the second group is 30%, there's still a 10% difference there. One group is 10% above the other group. With that, our ideas will be pretty much the same as a single proportion hypothesis test, just some slight modifications. The first step is to form a pair of hypotheses, your HO and your HA. For HO, we assume that P1, the first population proportion, is equal to the second population proportion. Regardless of the wording, we assume that the groups are equal. We want to see, do the statistics show otherwise? Do the statistics show that the first group is greater than the second group? That the second group is greater than the first group, or the first one is less than the second one? Or that they're just not equal to? And we'll know which symbol to pick based off of the wording. We haven't seen a not equal to just yet, but we'll see one in the next video or two. But if you see difference or change, was there a change from last year to this year? Well, it didn't imply that it had gone up or gone down, that it's just different, so that's when we'd use not equal to. In order to use the less than symbol, you would see something like less than or at most. In order to use greater than, you would see greater than or at least. Note there are no numbers to enter in here. It's just P1 and P2. You might not use 1 and 2, you might use PM and PW if you're talking about men and women. You might use PG and PB if you're talking about girls and boys. But that's really up to you as far as that notation goes. The second step is to check the central limit theorem, just like it was with 1 proportions. You want to make sure that you have a random sample. And you have a large enough sample size. And now, this time we're not going to use n times p and n times 1 minus p. We're going to use the actual number of given successes and failures are greater than or equal to 10 for not just one group, but for both groups. And I'm doing this because I'm using the actual because we won't have p. We don't have that, so we can't multiply in the sample size times t because we don't know what that is. We're just going to use the actual number of given successes, find the failures, and make sure they're both over 10. In order to run this hypothesis test and get its statistics for the third step, you go to Stat and Test once again, but this time you want to go down to number 6. If it's just one group, one proportion that you're focusing on, it's number 5, the 1-prop z-test. But if it's 2 groups and 2 proportions you're focusing on, you're going to go to number 2, the 2-prop, the 2 proportion z-test. When you hit enter, x1 is the actual number of successes for the first group. N is the sample size of that group. x2 is the number of successes for the second group. N2 is the sample size for that second group. We'll select our symbol once again based off of the wording in the problem, and then we just hit calculate. And we'll see our z-score, we will see our p-value, and we'll see both of our proportions. And then our final step for a two-proportion hypothesis test is to use that p-value that we have from our calculator and compare it to our level of significance, or significance level that will be given. And this is the same as we saw for the one proportion hypothesis test. And this is the same for all kinds of hypothesis tests, not just one proportion and two proportion hypothesis tests, but all kinds of statistical hypothesis testing. If the p-value is less than alpha, we have enough evidence and we reject HO, that they're equal, and we can say the data are statistically significant. The statistics back it up to conclude whatever HA said, that P1 was less than P2 or P1 was not equal to P2. On the other hand, if the p-value is greater than our alpha, we do not reject HO. There's not enough to throw that out. And the data are not statistically significant to conclude the idea of HA. One way to think about this is if the p-value is low, if it's lower than your alpha, HO must go. So it's a rhyme you can use to help you remember this. If the p-value is low, HO must go. We reject it. Also, our conclusion here about HA needs to be on the difference of the population. Not they're the same, but how they're different. Less than, greater than, or not equal to. We're going to look at two examples in the next two upcoming videos.